Hi guys, in today's video we will try to understand Liskov's substitution principle, which states don't ask about is a relation, instead check if it is substitutable by. So what does that mean? So is a relationship can be tricky at times, okay? So we should not rely on the is a relationship, rather we should check if the derived class can actually replace the base class. Okay, so let's try to understand this with the example. So say for example, we have a bird interface here, which has two abstract methods called beak and fly. So we expect that any given bird should at least have a beak and that given bird should be able to fly. But is it true for the case of ostrich? No. So an ostrich do have a beak, but it cannot fly. But we say ostrich is a bird, right? So this is true that ostrich is a bird, but at the same time, ostrich cannot fly. So it is satisfying the condition of is a relationship, right? Whereas it is failing the substitutability, okay? Because an ostrich cannot actually replace or substitute the word bird. So say for example, I'm saying bird can fly. So this is our base class bird. Can I now substitute this statement with ostrich can fly? So this is our derived class. Okay, so this is true here, but this is false. Okay, so that's the essential crux of the Liskov's substitution principle. So let's jump on to the code and try to understand the fix. Alright, now let's just create a package called Liskov and then create an interface and let's call it bird interface. Okay, and we can have a method called public void beak because a bird will have a beak, and then another method called public void fly because our bird is going to fly. Okay, so this is our bird interface, and let's just try to implement this interface with the help of ostrich class. Okay, so it implements the bird interface. Okay, let's add the unimplemented methods and let's put a simple message saying I have a beak. Okay, and then the fly method says I cannot fly, therefore I am sad. Okay, so as you can see, because of the bird interface, the ostrich is facing some issue while flying. Okay, because the ostrich cannot fly. Let's implement another class and let's see, let's call it sparrow. Okay, and similarly sparrow implements the interface bird. Okay, so similarly sparrow has a beak and it says I have a beak, and then it says I can fly and I'm very happy for that. Okay, so as per Liskov's substitution principle, the ostrich class is not fully substitutable because it cannot fly. Let's throw new runtime exception and it says I cannot fly. I'm sorry. I cannot fly. Could you fix me? Okay. And let's create another class, consumer class, and let's call it maybe a bird sanctuary. I'm sorry, century. Let's call the public static void main method here. Okay. So we create an instance of the class bird is equals to new sparrow. Sorry, it's bird interface. Okay, and let's call the fly method. And similarly, let's call it sparrow. We know sparrow can fly, and then we try to create another interface, another instance called ostrich, and then we try to make our ostrich fly. Okay, so ostrich is also saying I can fly. Why so? Oh, because we have initialized it with the sparrow itself. Okay, so now ostrich is complaining, I cannot fly. Could you please fix me? Okay, let's see how can we fix the ostrich now. So let's take this fly method out of this bird interface. Okay, let's take another interface and call it flying bird interface. Okay, so it is going to extend our existing bird interface. Okay, and let's take out this fly method from here and put it in bird interface. This will no longer push the ostrich interface to implement the fly method now. So we can just get rid of this fly method. So as ostrich cannot fly, let's remove it from there. And in case of sparrow, instead of implementing the bird interface, we will now implement the flying bird interface. So if you remove these two methods, okay, and implement the unimplemented methods here. So as our flying bird interface is extending bird interface, okay, so we are getting the beak method in the form of inheritance. Okay, so let's just put it back here. Okay, so now let's go back to our bird centric class and try to fix. So we can just call the beak method because the ostrich has a beak, and let's call the beak method on this one as well. Okay, so it is saying sparrow, and let's just change the interface here to flying bird interface, and this is now compliant with the Liskov substitution principle, and this is a happy scenario now. Let's run it. So sparrow now says I have a beak and I can fly, whereas our ostrich is now happy with a beak, doesn't have to forcefully fly now. So I hope this helps you understand the Liskov substitution principle, and if it is broken somewhere, how can we fix it? We need to revisit our interfaces in order to fix it. If you found this video useful, please do share it with your friend and subscribe to my channel. Thank you.